Hello? Can you hear me, Chris? 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 Okay, so now you can hear me through my mic, but that's all you can hear, right? Okay, so it is now 12 p.m. Eastern Time, so we will go ahead and get started. So my name is Julie Butler. I am a professor of physics and data science at the University of Mount Union, which is a small liberal arts college in Northeast Ohio, kind of near Cleveland. And so while last week Chris and Scott introduced you to some STEM coding activities mainly involving physics, today we're going to do something slightly different. So the data science topic today is going to be data cleaning. Data cleaning being the process of taking a messy data set you might find somewhere on the internet and transforming it into something that you can actually use in spreadsheets. And instead of a physics application here, we will be looking at a data set based on ecology. But data cleaning is not just based on ecology or any one field. For example, on Friday, Scott inadvertently showed you data cleaning in spreadsheets while doing the object tracker activity where he went through his data and removed parts of the data which were badly formatted or that did not match the model that he was trying to fit. So the activity we'll be learning today is based off of this activity from the organization Data Carpentry, which is a great organization which provides a lot of different data science activities across many different disciplines. We'll be taking the data set that they provide here for doing data cleaning with ecology and using it to see how we can apply some data cleaning practices and make it look a little bit better and make it more functional so that we can do some analysis with it. I would like to point out that if you go to the link in the description of this video, you can find the Ohio Learning Standards for mathematics, specifically in the field of statistics and probability. If you scroll down to page 6, it outlines how a high school statistics class is different than a high school data science class. And one of the main differences there is data cleaning. In a normal stats class, while you use data, you typically are given a very nice data set that doesn't need anything done to it before you can use it. Whereas in a data science course, you will actually go through and learn how to clean data. That is, take a data set which may not be initially usable, but make it usable so that you can do your stats on it or make graphs with it or anything else you want to do with it. Next, I have this nice diagram here from Kelsey Badger, who is a librarian at Ohio State University and who is also a member of our STEM coding team. Tidy data, or data cleaning, is a standard way of mapping the meaning of a data set to its structure. And there are a few ways in which you can make a data set tidy. If we think about putting data into a spreadsheet, we want to make sure that each variable in the data set has its own column, so things are not being messed around or in different tiny tables in a spreadsheet. Every variable has its own column. Every observation has its own row, so each individual data point has its own row. There's not going to be split amongst several rows. And each cell has a single measurement, meaning that each data cell in a spreadsheet only has one single piece of information. And so now let's see how this works in practice. So on the Discord channel, if you're a member of the Discord channel, in the data science channel, I attached this Excel sheet, and this is what we will be using today. If you are not already a member of the Discord channel, the join link is in the description of this video. And so this spreadsheet is taken from the Data Carpentries, and it shows some ecology data. The idea being that you were given this data from a field scientist who was measuring 3 different species of animal, gathering the date in which they collected the animal, the plot of land in which they found the animal, the sex of the animal, and the weight of the animal. And they want us to take this data and make some nice graphs and do some analysis on it. However, the way they've split this data set up is not with the rules that we just learned. Instead of having one spreadsheet where each variable has its own column, each data point is its own row, and each cell only contains one piece of information, they instead have three small tables, which are separated by the species type. Some of these cells even have multiple pieces of information in them. So for example, the weights over here in these two cells have a note that the scale is not calibrated. So there's two pieces of information in that one cell. But this is a pretty realistic example of a spreadsheet that either would be sent to you by other people or that you would find online. A spreadsheet in which it might be easy for the researchers to fill in the information, but maybe not so easy for you as a data scientist to analyze the information. But with some knowledge of spreadsheets, we can actually take this data and make it look a lot nicer. So let's start by making a new tab on the spreadsheet where we will collect our data in a more manageable manner. We're going to take one column per variable we have. So we have the date the animal was collected, the species of the animal, the plot of land it was collected on, the sex of the animal, and its weight. And now I want to take the data from the previous sheet and import it here. So for the date, I'm going to type equals, go back over to the original data tab, and click the date. And that will import it here. The species, since that is the title of the little table here, I will have to import myself, so just type DM for the species name. For the plot of land this animal was collected on, again, I can type an equal sign, go back over here and click the plot number. Same thing for the sex of the animal. And for its weight. Note that for the first animal they have denoted here, they did not collect the weight of it, so this is a blank cell. And that is fine right now, but I'm going to go ahead and click it so that this sheet knows where to pull the data from. And so now I have the entire row of data for a single animal or a single data point, and I want to expand this to include every single data point on the previous sheet. And while it would be pretty tedious to do this by hand, clicking every single cell in the previous sheet, Excel is actually pretty smart, as Scott showed you on Friday, at finding patterns. So I can just highlight this entire row and drag it down. And it's going to automatically import all the data from the previous spreadsheet. And I can keep going until I start seeing data which doesn't make sense. This last row here, where a female animal weighed 37 grams, corresponds to the last row of this tiny table here. And so once I click and dragged it past the table, it just started defaulting to default values instead of filling in the actual data. So I could just highlight these and delete them. And now I can start filling in the other two tables in the same way, where I will hit equals, click the date. Here the species is DO, so I will add that in. Click the plot of land, click the sex of the animal, and then click its weight. And then do the same thing where I highlight it, and I drag down until I start getting the default values, meaning I've collected all the data from that table. And now the same thing for that last little table on the original sheet. The species is DS, and then I will get the plot of land it was collected on, its sex, and its weight. And drag down to collect all the data. And so now I have all of my data in one nice spreadsheet, following the rules we saw on Kelsey's PowerPoint slide, which is that every variable, the date, the species, the plot, the sex, and the weight has its own column. Each data point is now its own line within that spreadsheet, but we're not quite perfect yet. We still have a few problems. And so let me, before we continue, make this data slightly bigger so it's easier to see. And just to make it apparent that this first row is a header and not data, I'm going to bold it so that it kind of stands out a little bit. Currently, this spreadsheet is sorted by species, which is fine, but maybe I also want to sort it by something else. I have a date column where the date of which the animal was collected, so it might be nice to sort by that. So what I can do here is highlight my columns of data, go to the Data tab, Sort, and I want to sort the date column from oldest to newest. We'll leave it at that, but you could also change it from newest to oldest if you desired. And if I click OK, now I have my data. It looks pretty similar at the top because all of the DM species were collected in July, which is the earlier dates. But if you scroll down, you notice there starts to be some overlap between the other species. So part of the year-long data science course that STEM Coding is developing, the end of this course will allow students to take the Excel certification exam. Part of that exam is using Excel to handle date data. And since we have dates right here, I'll take a second to show you some of the features Excel has which allow you to analyze dates. So I'm going to right-click on this column B, and I'm going to Insert, which will add a new column to the left, and I'm going to do that 3 times in total, so I have 3 new columns. I'm going to title this first column Month, the second Day, and the third Year. And hopefully it is obvious by what I title the columns, meaning that I chose good column names, that I want to extract the month, the day, and the year from the date at which the animal was captured. And it's not that much data in the spreadsheet. There's only 38 rows. So I could go through and do this by hand, but it is a lot easier and faster if we let Excel do it. So to get the month out of a date, you type an equal sign. In all capital letters, the word month, parentheses, and then click the date that you want to extract the month from. Note that it's formatted kind of strangely here because it is trying to auto-format this cell as a date where I want it to just be a number. I only want it to be a 7 representing July. So if we go to the Home tab here, this little drop-down menu here allows me to change this cell from a short date format to just general. All I want is the 7, telling me that the month of this collection was the 7th month, or July. To extract the day, I can just type equal sign, all caps day, parentheses, click on the date, and press enter. And same thing, it auto-formatted to a date, but I don't necessarily want that, so I'm just going to go with general. And finally, for the year, equal sign, Y-E-A-R, parentheses, click your date, change the format to general. And so now I want to apply those 3 calculations to every row of my table. And what I could do is just go through and type it in every single cell, going all the way down to the bottom, but that's going to take a while. Something that's easier to do is highlight those 3 cells that we want to apply to the rest of the spreadsheet. And this little square at the bottom right corner if you double click it, it will auto apply the same formatting all the way down, such that for every date we collected the animal, we have the month, the day, and the year in separate columns. And while this might not be super useful for this particular application, knowing how to work with dates in Excel is a very important job skill that we can give students as they're learning these kind of things in high school. So next, we have some more data cleaning practices we want to do. Notice that in the original tab of data for the DM species, 3 of the weights were blank, which is fine. That just means they collected the animal, but they did not manage to get the weight of the animal. But when we transferred it over, those blanks became zeros. But this is a problem because 0 being a number means that if I try to take the average of the weight column, those zeros would affect it, and something cannot have a weight of 0. And so I want to make sure that I go through and I delete these zeros from my data set so that they won't be counted when I try to do different calculations with this data. Now what I want to do is create a graph of the dates versus the weight of the animal collected on that date. But notice that if you highlight those 2 columns and go to Insert and Recommended Charts, just like Scott showed you on Friday with the object tracker data, if you click on the Recommended Charts button, it does give you some options, but it looks kind of weird. If you notice the column of, or the title of these charts, it has weight, which is what we want to graph, but a whole bunch of other things as well. It looks like that when these researchers were collecting the data, at least for the DM species, instead of just putting a number in the weight column, they put the number in G, representing grams, the unit of the weight of the animal. And while it's good to have this information, it's not good to have letters and numbers mixed together because Excel doesn't know how to treat that. So what we want to do is go through all of these data cells and just delete the G on the number. And now we have just the weight of the animal as a number. And you can tell that Excel now treats it as a number because instead of being left align when it has the G, once you delete the G, it'll right align. Excel will automatically left align text, meaning non-numeric data, but right align numbers. So that is a good way to determine whether Excel thinks your data is a number or not by seeing whether it is left aligned or right aligned. So now I fixed those, but we still have this to deal with. 132 grams is the weight, but scale not calibrated. And what that means is that before they took the weight of the animal, they did not calibrate the scale. And so there's a few ways you can interpret it. You could leave these data points in originally and see if they sort of fall into the expected values, or we could just remove them entirely because if the scale was not calibrated, we're not sure how accurate they are. But what we don't want to do is do what's done here and have a number and the note in the same cell. Remember, we only want one piece of information in a cell at a time. And so what I can do is go up here to the top and make a new column called Notes. And in this column, I can add any notes I have or comments about particular points. And so I'm going to take these 2 data points here and move them over to the notes column and just leave the weights column blank because since the scale was not calibrated, we don't know if we can trust that data. It's probably best to not include it in any graphs or calculations we're trying to do. Notice that this notes column is slightly too narrow to fit the new data. There are 2 ways to fix this. You can either go up to the top and hover between the I and the J on the line until your cursor turns into the little 2 arrows and slide it over until it's the appropriate size. Or instead of sliding, you can double click, and then Excel will auto size that column to be the correct dimensions for the data you have in it. And so now I think I have a clean data set. I have each variable of data has its own column. Each row in the data frame is its own data point. There's not a mix of letters and numbers. Any data that should be numeric is numeric, and any data which is not numeric is the correct label. Any notes I had on particular measurements are now in the notes column and not mixed up with the data. So I think I'm good to start doing my analysis. So let's first start with what we were originally trying to do. Create a graph of the dates and the weights of the animals which we were collecting. And I want to make specifically a scatter chart. So I'm going to click the little down arrow on this icon and then click on the scatter chart. And it auto-made a chart of date versus weight. Excel will automatically graph dates for you, which is very handy. So you don't have to go through and try to deal with graphing dates separately. You can just highlight the dates and it'll graph it for you. You can go in and add different chart features if you want, but we'll just leave it as this for now because this lesson should only include data cleaning, not necessarily making pretty graphs and things in Excel. Another thing we can do is maybe we don't want to just plot the weights of the animals. Maybe we want to plot what ratio of the animals are female versus male, so the sex column. Here, instead of the data being numbers, the data are letters, F representing female and M representing male. We call this categorical data because the data can only fall into one of so many categories, in this case, male or female. But if I want to graph this data, I highlight the column, I go to Insert, maybe I want to make a pie graph. Or if I go to Recommended Charts, there are no recommended charts for the data I have selected because it is categorical data and not numeric data. And so there's one last step of data cleaning that I'll need to do in order to take this data from the categorical data that was collected by the scientist to something I can use to make a graph. So I'm going to go over here just to a blank spot in my spreadsheet, and I'm going to type male and female. Bold it so that you know those are headers. I want to determine the number of times the letter M appears in the sex column of my spreadsheet. And now I could go through and count it. It's not that much data. It wouldn't take that long. But you don't want to necessarily do things by hand that don't scale. So while there's only 37 data points in this data set, you might also want to do this with data sets which have hundreds or thousands of data points, and therefore doing things by hand becomes very tedious. And so instead, I can use Excel and a little bit of programming in order to get the number of male entries in this column. So I can hit equal to start the Excel, count, C-O-U-N-T, if. And now I want to highlight the range of data that I wanted to count. So I'm going to highlight my data, comma. Now I want to type a quotation mark and the series of letters I wanted to count. In this case, just M. But if it was, for example, in the species column, I might want to type DO within the quotation marks. After the in quotation mark, add another parenthesis to close the first one. And if we hit enter, it will automatically count for us that there are 10 occurrences of male animals in our sample. I can do the same thing for the females, equals, count if, parenthesis, highlight your data column, comma, quotation mark, F this time because we want females, another quotation mark, and then a parenthesis. There are 27 females in the sample. Now, if I highlight these 4 cells and go to recommended charts, we now have options. So I can make a bar chart, I can make a pie chart, which is what I wanted. And now I have a pie chart for my categorical data. Even though I had to do a little bit of extra work to get it, it wasn't so bad. And now finally, maybe I want to find the average of the weight column. So I'm going to go down here to the bottom and type average. And now to average the weights, instead of over here, where I would have to try to find the average of 3 separate columns, the beauty of combining all this data into one is I can just do it once, type equals average, parentheses, highlight the data I want averaged, and now I have my average weight. And you can do things like standard deviations and all sorts of different statistics in Excel, and it's a lot easier now that we've done data cleaning and gotten the data from this format, which was easy for people to enter data in, but not so easy for us to work with. And in just the 26 minutes the stream has been going, we've taken this data and transformed it into something that we can easily graph and we can easily do statistics on. And so this is a very nice activity to introduce your students to data cleaning, because you could use this exact spreadsheet and have them work on this ecology data. You could introduce data cleaning into the object tracker activity that Scott showed you on Thursday and Friday, because there were different cells that you had to delete, either because they were not numeric data, they said object out of range, or because they were a little bit skewed because the object wasn't entirely in frame. And so there are many different applications in STEM coding activities and in other activities as well, where these skills can come into play, and they're very useful for your students to learn. And so I'm going to just, as an in thing, rename this field data formatted. And now I have all of my data ready next time I want to use it. And so I think that is all I have for everyone today. I will check the chat to see if there are any questions. And you could also post your questions to the Discord. But if there are no questions, then I think that we'll go ahead and end the stream here. And we will see everyone back here tomorrow at 12 p.m. Eastern Time to learn about different STEM coding activities.